Okay guys, today we're going to do 6.3, which is factoring polynomials, which is really going to take those factoring quadratic skills you learned last semester, and we're going to build on those and take those into higher degrees. Okay, so we're going to start out just by warming up, doing some factoring of quadratics just like we did last semester. So this first one, we're just looking at, we have a greatest common factor of 5x. So put that 5x out front, divide both by 5x, and we get x plus 3. And we're done. Next one. We have a trinomial. A is greater than 1, so I'm going to start out with a times c. 2 times negative 6 is negative 12. I'm looking for two numbers that multiply to be negative 12 that add up to be positive 1, because that's 1x in the middle. And comes in my head right away, 4 and negative 3. So I'm going to rewrite that. 2x squared plus 4x minus 3x minus 6. So what we're doing here is we're splitting the middle. I'm going to group. 2x is common in the first group, so I'm going to put that out front. Divide both by 2x. I get x plus 2. Common in the second group, I can divide both those by negative 3. So I'm going to put that out front. Divide, and I get x plus 2. Now my two factors, my 2x minus 3. And then my x plus 2. Okay, that's it. Let's move on to number 3. Number 3 is a binomial. I see a perfect square and 100x squared minus, and then another one is minus 49, right? So I'm immediately starting to think shortcut, difference of squares. Square root of 100x squared is 10x. Square root of 49 is 7, so I'm going to do 1 10x plus 7, and then the other is 10x minus 7, difference of squares. Okay, next one, I see a perfect square up front, 25x squared. That would be square root of 25x squared is 5x. Square root of 9 is 3. Really, it could be plus or minus 3, potentially. Could be that other number. So 5x times negative 3 is negative 15x, which is half of negative 30x. So this is a perfect square. And I get 5x minus 3 squared. Okay? When we're factoring, just talk about how we're going to attack these factoring problems, okay? Always the first step, just like with binomials, the first step is, or just like quadratics, the first step is going to be factor the greatest common factor, G, C, F, okay? After that, we're going to start looking for some perfect squares. Look for those perfect squares. Those will help us find shortcuts. So look for our squares. And then we're going to identify, is it a binomial? Do we have 2 terms? Is it a trinomial? Or does it have 4 terms? So 2, 3, or 4 terms. How many? And once we identify that, we can develop our strategy for how we're going to factor. Okay? If we have a binomial after we've done greatest common factor, we're starting to think, is it a difference of squares? That's our question we need to ask ourselves. Okay, if it is a difference of squares, we know to do the parentheses, x plus a number, okay? And then we're also going to do an x value minus a number, okay? We also will have a coefficient in front of those. Sometimes it'll be c, sometimes it'll be something else, okay? If it's a trinomial, we have 3 terms, then we know we're probably going to be splitting the middle. Okay. I want to highlight back up here. We have the plus and then the minus for difference of squares, right? That's the main thing we're looking for there. Okay. If we have 4 terms, we need to remember to factor by grouping. Okay, that's going to be our main strategy for factoring when we have 4 terms. Okay, moving on, let's look at example 5. First off, I want to do the greatest common factor. 60, 70, and 20, those can all be divided by 10. These also all have an x value. So I have a common factor of 10x. So my first step is dividing each of those by our common factor of 10x. 60x cubed divided by 10x is 6x squared. 70x squared divided by 10x is 7x. And then 20x divided by 10x is 2. Okay, now we want to focus with what we have here in the red inside the parentheses. Okay, and that's going to be splitting the middle. So I'm going to multiply a times c. 6 times 2 is 12. 2 numbers that multiply to be 12 that add up to be 7 would be 4 and 3, right? So we're going to split that middle, 7x, into 4x and 3x. Bring down my other terms, 6x squared plus 4x plus 3x, and bring down my 2. Then we'll group. Common between 6x squared and 4x is 2x. Divide both those by 2x, and I get 3x plus 2. In the other grouping, the 3x plus 2, I don't have anything in common. So I just divide out by the plus 1. And I get 3x plus 2. And my 2 factors are 2x plus 1 and 3x plus 2. Now something I can't forget to do is I need to make sure I didn't forget about this 10x, okay? Sometimes it's good to continue to write that the whole way down, just so we don't forget about it, or we can just bring it down in the end like I did. And that's our answer for number 5. Moving on to number 6. Again, we have a common factor. We can divide 25, 30, and 40 by 5, and that's a negative out front. Okay, so with that lead coefficient being negative, I also want to divide out that negative. So I'm going to divide all 3 of these by negative 5. They all have an x, so negative 5x. Okay. Negative 25x cubed divided by negative 5x is 5x. I'm going to put my negative 5x out front, my common factor. 30x squared divided by negative 5x minus 6x. I just realized I missed my square there. Sorry about that. And 40x divided by negative 5x is minus 8. Okay. Again, I'm going to multiply my a times c. My 5 times negative 8 is negative 40. Thinking of factors that divide to be negative or multiply to be negative 40 that add up to be negative 6 would be negative 10 and 4. So I'm going to split the middle, negative 6x with negative 10x plus 4x, splitting that up. Bring down my other terms, minus 8 and 5x squared. Then group. Common between 5x squared and negative 5x is 5x. $5x squared divided by 5x is x. Negative 10x divided by 5x is negative 2 or minus 2. 4x minus 8, common between those. I can divide both those by 4. Put my plus 4. 4x divided by 4 is x. Negative 8 divided by 4 is minus 2. 5x plus 4 is one factor. X minus 2 is my other. And once again, I cannot forget about that negative 5x. I factored out in the beginning, so I'm going to bring that down. And I'm done. Okay, number 7. Common factor. I can divide both of these by 3x. So 3x goes out front. I get 4x squared. Negative 75 divided by 3. Negative 25. The x's divide to 1, so they cancel. Now I have a binomial inside the parentheses. 4 is a perfect square. 25 is a perfect square. There's subtraction in between. The alarm should be going off, okay? I should recognize that this is a difference of squares. Square root of 4 is 2. Square root of x squared is x. Plus the square root of 25, which is 5. Then we get 2x minus 5. Can't forget to bring home that 3x. Bring that down, okay? 3x times 2x plus 5 times 2x minus 5 is my factored form. Moving on to number 8. We have 4 terms. We do not have a common factor here, so I'm going to try to factor by grouping. First group. Second group. Okay. Common between the first group, 2x cubed and x squared. I can divide out my x squared. So this is a lot like split the middle, which is also factoring by grouping. 2x cubed divided by x squared is 2x. X squared divided by x squared is 1. And we can look at our negative 8x minus 4. I can divide both of those by negative 4. That lead term is negative. That negative 8x is what makes sure that this is negative there. Okay, that's what's telling us to have that negative out front. Okay, negative 8x divided by negative 4 is positive 2x. Negative 4 divided by negative 4 is plus 1. Common here. And when we have our x squared minus 4, I'm going to go ahead, standard form has that highest exponent first, so x squared minus 4. And then we have 2x plus 1. Okay, now I'm looking at binomials here. And once again, we have a perfect square x squared and a perfect square 4, okay? That's where those alarms go off, and we have subtraction again. So the square root of x squared is x, the square root of 4 is 2. So x plus 2, x minus 2, that difference of squares. I have to be able to see that. And then 2x plus 1 comes down. Moving on to number 9. I'm not seeing any factors, but I do have perfect squares, okay? 25 is a perfect square. X to the 4th is a perfect square. 64 is a perfect square. And it is subtraction again in between. So I should be looking at difference of squares. Square root of 25 is 5. Square root of x to the 4th is x squared. Square root of 64 is 8, so plus 8. And then 5x squared minus 8. And I'm done. Okay, now you should go ahead and complete the practice work. Let us know if you have any questions. Thank you.